Good afternoon to all of you and warm welcome, and I think I'm meeting you once again after yesterday. So firstly, my team here has advised me not to teach anything. They've told me don't sell anything. So I have that in-between phase that I need to maintain right through the next 15-20 minutes. So what we thought we'll do is, from where I left yesterday, continue on this context and course that we've had on digital transition, right? So what we do around the world and what we do here has a lot of impact in the way people live and advance the way they work. So what I'm planning to do is and what I do otherwise for a daytime job is I manage all the industry verticals. So from across the industry verticals, not just academia, I will just speak about some of the highlights that we've had, which is what we've done with these verticals, with these governments, or with the financial services institutions from a digital transition part. So in brief for us, in transition and definition, in digital transition, everybody is doing 3-4 things. One is the fact that they're using a lot of the machine generated inputs in decision making, which is making it autonomous. The second thing that they're doing is they're making it a lot more programmable. Every enterprise, be it an academic institution, a financial services institution, etc., is becoming programmable in the sense that a lot of microservices and mini services are launched. I'll speak about 1 or 2 examples about that. And then of course the whole context of being connected, not just from a Wi-Fi perspective, but IoT and universal IoT platforms and the like. So as a result, everybody gets empowered. So if you just talk through, I'll just talk through some of the examples that we've had. So let me start with India itself. So we've had a lot of this thing going around the financial inclusion. So we very closely aligned with this architecture with some of you from the research institutes who are involved with this evolution of this architecture called the JAM architecture. It's called the Janadhan, Aadhaar and Mobility architecture. So alongside with that, we did a lot of the payment banks in the country, and the largest being the Department of Posts. So outside, one of the things that we've done is there are these regular enterprises which choose to transform or transition digitally. There are also these born in the cloud native companies that do a lot of work for almost all the financial institutions in the country. I just want to ask you a question. So how many of you in the recent past have generated OTP using a banking service? How many of you? All of you? Almost every one of you? So that OTP is not generated by the bank. It is generated by a born in the cloud company called Wibmo, and Wibmo actually runs that entire scale of operations on a composable infrastructure that HP provides. Composable in the sense that it really boots to real-time workloads. It's very intelligent in the sense that it's software defined and the likes. So the second, third examples are the state of Rajasthan, which is the desert state actually. My friend will be very happy because he's from Aruba. So the entire desert state of Rajasthan, we've made it Wi-Fi enabled, and in that context, all the digital services across any of the states, taluks, the schools that you go to inside the state and the district, they're all Wi-Fi enabled and the likes. So the other last example from India perspective is the fact that when the financial inclusion thing was being spoken about as a digital transition thing, we kind of scaled the whole infrastructure up. So for example, today, while they have about less than 1 billion accounts, I guess, you could do up to 2 billion accounts, and we performance characterized the whole thing to include things like end of day, end of a week, and end of month operations, so that they could do it very freely. So apart from this, some of the other digital experiences we've had is the fact that if you are anywhere in the state of Madhya Pradesh, then all of that whole command center that runs in Bhopal, and which we just got the Prime Minister's Award for being the best smart city project in the country, was done by HP, and that's cloud-based software that runs out of a console which is based in Bhopal. Elsewhere around the world, a lot of memory-centric, memory-driven computing is what we are involved with as a concept and technology, going away from copper. And some of the projects we involve in, is one which is in the cure of Alzheimer's. So that's one thing. The last one is a very serious project about which I'll speak to you in a lot more detail, because Mars is not one of those things like Moon, which is a low Earth orbit satellite. Mars is about 34 million miles. So I have a separate slide on that to tell you what we've done, because we've split the compute, which is normally high performance compute, between what we have in the Earth station and having all of the artificial intelligence in the spaceship itself. I'll speak about it a little more. Kamal, you just go on. So our context in this whole thing is the fact that of all of these things that happen in this space of digital transition, our view about life is that the whole world is going to be hybrid. And all of these hybrid models would mean that you would have some of your workloads in premise, which is, it could be an AI workload, it could be, object storage workload and the likes. But you would have a larger bit in the cloud, and somewhere all of these need to be interoperable and going forward, moving up and down. So towards that, most of our investments, these are inorganic investments. There is plenty that is being done in-house as well, which some of my colleagues will cover later. But what we've done is we've acquired a variety of companies that primarily help transition your workloads from wherever you are and have a seamless experience. So notable amongst them are three. Primarily, one is the fact that Plexi, which is a company that we acquired recently. What it does is a software-defined switch, but it more helps in composing workloads at the rack and tower level. So you no longer have a physical port, you have more virtual ports. The second is Red Pixie, which is more to do with consultancy and app in the cloud, more around the Microsoft Azure. And we have several institutes in the country which is actually doing a lot of HPC activity even in the Azure cloud. The last, of course, is Cape Networks. I have my colleague here who will watch me very keenly to see if I am saying the right things, Shantanu here. So this is, it's lending a lot of artificial intelligence to the Aruba networks as a whole. And what it does is the fact that it provides service assurance through a sensor-based network. And it can be very network agnostic while it's providing the service assurance. So, here is what we do in all. So what we do is we primarily focus on the technology transformation, which is number one for us. We believe the whole world is going to be edge-centric and it's going to be data-driven, and all the apps and data don't have a very specific place to reside. And while doing that, most of all that we design is going to be completely software design and in a manner that it can be cloud to multi-cloud and vice versa, and you would have a single pane of glass to see it all together at one place, irrespective of where the workload is or where they actually reside. The other two elements are far more important, because if you're doing a digital transformation of any kind, it is the culture that matters most. In a higher education institute like this, while you can have processes and systems, you need a lot of cultural reorientation to get your digital transition right. So hence what we do through our advisory and professional services is the fact that we advise to a large extent how you could heighten user experiences or student experiences, so to say in this case, by a variety of methods. So that's the other thing that we do. One of the least understood elements perhaps in the context of digital transition is the fact that there's a lot of financial restructuring that we help do, primarily because you would have a lot of underutilized assets during the course of any IT journey, and we help rebalance that in many, many ways. So our context as to the future world and hybrid world is the fact that our objective is to offer EaaS, which is everything as a service. So in the hybrid model, you would have flexing capacities of varying kinds of storage, of compute, of software and the likes, and the fact that all of this would be available through an offering which is everything as a service. So today we even offer database as a service, Postgres and the likes. We offer backup as a service, etc. So from this point on, this community here is largely perhaps interested in these 3 or 4 areas, right? Which is modeling, simulation, deep learning, analysis, managing data, etc. So as my team advised, I'm not going to teach you about anything of these, because this is what you do fundamentally for a living. However, some of these are used very interchangeably, like for example machine learning is used in a variety of ways, but in each one of these areas we have case studies from around the world. I'll just focus on just 2 or 3 of them, primarily because of the fact that it is a very vast subject. So we do some on SVM, we do some on random forest, and the likes. So I don't want to go into all of that, but very specific to what we'll do here is just a slide on what we do for this segment. On HPC, there are 2 challenges. One is the fact that you need to have highly scaling, highly cooling, highly dense, and always available systems, which can actually do 2 things. They are firstly massively parallel, and the second part, the fact that they are handling very large unstructured data sets. So all the components that we have and the elements that we have in our portfolio covers these 2 or 3 aspects in very many ways. So I'll just take you through just exactly a slide and highlight 3 products that actually talk about what we do. So firstly, from a high performance computing perspective, since the acquisition of SGI and a little prior to that, 35% of all the top 500 supercomputers around the world run on HP. 35% is what runs on HP, and it could span across any segment that you think of. It's weather, it's high performance mathematical modeling, whichever segment you think of, it is there. From an India perspective, about 50%, 50 and above of the institutes from install base, and 6 out of the 9 listed of the 500 that we spoke about is on HP. But notable is the fact that we very focused on petaflop computing, which is that one product called the HP SGI 8600, which is primarily a refined version of the previous generation ICE XA, if you've heard of that product, because it ran most of the supercomputing sites in the country. It's water cooled, highly compute dense, all of that. The second and third products, the Apollo 6000 primarily is a rack scale version of the same thing, very high density from a compute standpoint. And the third product is what we call the Apollo 2000, which is a scale out cluster. And with that can go a variety of combinations of your GPUs, up to I think 8 GPUs per node. But what's interesting is that we have offered these combinations with a variety of interconnects. It could be InfiniBand, it could be OPA, anything else so that you think of. So there are varying combinations available, and what we offer specifically is the HP Performance Suite, which is a software stack. And irrespective of the environment that you come from, we could do work with you in either performance characterization or helping you scale. So most of the recent work that we've done in our labs, which is in Bangalore, is to see how some of these projects that are a lot of the academia is involved in moving from peta to exascale, and that's something that I'd like you all to come down and see for yourselves in Bangalore, which is our labs. So just 2 or 3 case studies. Yesterday I briefly spoke about this, but for most of you who moved around, Carnegie Mellon and other places, so they largely use the Pittsburgh Supercomputing Research Center for all of their computing or research work. What Carnegie Mellon researchers have chosen to do is the fact that they're using very advanced artificial intelligence, and they're using that AI advanced primarily to do one thing, which is to see how this aspect of machine can actually start simulating strategic reasoning better than humans. So that is the core of this effort in that project. So any one of you can go Google Carnegie Mellon's PSU, and then you'll come out with it. And what they've also attempted to do is to do this with incomplete sets of data to see if they can get to a final conclusion. And they have come to a point where they have incubated a company which does a lot of strategic consulting work basis this. What we put together is a very new kind of architecture here called bridges. We use a part which is SuperDOME X. There is a large part which is a scalable cluster using the Apollo 2000 the likes, and about 50 odd of them, about 800 of them in all is coming together in a cluster. But what it helps do is provides quicker results for Carnegie Mellon along with the Pittsburgh Supercomputing Center. So there is a bit about what the head of IT or the chief researcher has said about himself, so that I won't read out. Kamal, if you can just go past to the next one. So for most of you very technically inclined, and you know what happens in this kind of environment, this is what is happening there. So the second is a company called Hudson Alpha, who's involved in largely cancer research and cure. There we again, to the point that I mentioned earlier about having infrastructure which is composable, that is booting to workloads and specific to workloads in that institute. We have this case where they handle data types 10 to the power of 30 and beyond. So that is the kind of work that's happening with Hudson, and what they do is what is available in the next slide. So Kamal, yeah. So there's quite a bit of data that's generated, but I think handling, analyzing it, and providing that in varying facets of the actual research requirement is what we are kind of very specifically involved in here. Of course, You could go back and see this as even a Google search saying Hudson Alpha, and then you'll get to what we are doing in this area. The last one is last two examples, of course, is we involved with the Purdue University. I mean, obviously everybody has researched and figured out that by 2050 we're going to require the possibly twice the tonnage of food that is today available. So we involved in a project with Purdue University where we are using IoT sensors and the likes and agricultural fields, vast areas are connected, and what we're doing is a variety of things there. We're regulating the gains, the harvest. Not only that, things like irrigation, flow, this, that, and the other is monitored, and there is a whole host of things which is covered by our universal IoT platform and Aruba together to achieve that. Kamal? So yeah, I mean, they've chosen to call it digital agriculture, but yeah, I mean, that's what we do with the Purdue University. So from this point on, yeah, I will go to this last bit, which is about NASA, what we're doing with this company called the SpaceX. It is actually founded by Elon Musk, the otherwise very famous person. So this was launched, I guess, about just under a year ago, and it's perhaps closing in on Mars. So Mars is firstly it's not a low Earth orbit satellite. It is 34 million miles from here, and very often when you're doing mission critical work with solar flares and the other likes, each byte of data which goes back and forth takes about 20 minutes because the time taken to reach Mars is 1 year for the spaceship. So what we've done is split the whole data up and converted a part of the spaceship, also because of the fact that there were issues around how much of tonnage can be sent out. It's a 20 to 30 metric ton vehicle. So what we've done is we've done a whole lot of hardening, and NASA puts the system through 143 different types of tests. So we've done a lot of software hardening on this. We've used here is the building component of one of the top Super 9 computers called the Pleiades, and with that what we've achieved is we put artificial intelligence in the spaceship itself, and we moved the rest of it here. By doing this, what we have achieved is we've reduced the latency on communication down to real time, like it were a flight to moon. So with that, it becomes real time, and all of the command control for the spaceship happens real time. So this is a very interesting project, and I guess if you did a Google search on that, there are some videos available as well. So a lot of work around HPC of varying kinds, splitting AI workloads, very specific to genome sequencing, factoring, and the likes, plus the fact that the regular HPC, which is of the kind that I just spoke about, is what we are involved in. But what gives me great pleasure is that what we're doing is, from a HP point of view, is that digital transition as a much wider topic for us is not limited to just HPC or AI or machine learning. It spans across, and in varying ways we reach the customer, the social ecosystem around the world and around the country here because of the kind of projects that we're involved in, and those are some of the things that I spoke about. So with that, I'm reasonably down to my last slide, where I wanted to thank all of you for the time, and I hope we kept it as crisp as it should be, and I put none of you to sleep. And as my team advised, I didn't sell, I didn't teach. So so that's the end of what I wanted to say. Thank you very much, and Kamal, thanks. Thank you.
Show up every day. What's the point? To advance the way people live and work. To keep the world moving forward. Not just dream things or plan things, but roll up our sleeves and make a difference. To bring together the brightest minds and build the foundation for a world where everything computes. To take the kinds of ideas that make you go, what? No way, and help make them real. It doesn't always get our name in the headlines. Most of the time, that credit goes to someone else. These guys. Those guys too. And honestly, as their partners, we wouldn't have it any other way. But headlines or not, what we do here matters. Because we are the invisible power behind so much of what makes life work. We help make this happen. That too. Yeah, even this. We're working to help cure Alzheimer's. We're building servers that get flights to their gates early. Does that matter? They probably think so. We're helping to put high-speed internet where it never existed. Building the world's greenest supercomputer. Helping to model the universe. On top of that, we're volunteering, donating time and effort. All of us at Hewlett-Packard Enterprise. Her, him, yeah, everyone. So when someone asks what we do here, we tell them we imagine and build technology that never existed before. We take them through that whole list. Or if we don't have time for all that, we tell them this. We're working to leave the world better than we found it. So what happens next is going to be extraordinary. We are HPE.
For a university like, I'm from MU, so I'm asking a question very specific to MU. Let's say I'm trying to establish an HPC in MU. HPC infrastructure will be used by few departments like physics or fluid mechanics, or not all, there are some 100+ departments, but some of them will be needing it for their research support. So in terms of planning a scalable and infrastructure for HPC, because when you set up there is a funding need and funds are not easy to come from, because in a central university fee structure is not like private. So trying to set up an HPC, is there any checklist or a framework or a classification list available that can help us move forward in terms of having a affordable HPC solution which can be augmented later basis the future needs?
Sure. So firstly, thank you for the question. So we have an advisory service which is specific to academia. It is a sort of a corporate advantage program that we have for all the academic institutes. What we do is we come around, help you plan, but from a technology perspective, what we have are scalable. 2000 spoke about, but you grow those sectors which are kind of scalable at an appropriate time. So you could just choose to kind of size up just 2 or 3. I don't know why this is an issue, but
because in terms of ROI, it makes better sense to have some infra, use it to the potential, and then scale it up.
No, just to explain that, so with all the IITs and perhaps some of the other CMAC, like CSIR, we started small always with all of it. So we started with just a few nodes and then scaled it as time went on. But yeah, we have an advisory service and a corporate advantage program for academia that covers both the elements. We can size something up, basically what those two things, some of the other guys.
So it'll be great help if we can explore that option to help the specific departments. I mean, I have some outstanding requests. Okay, thanks a lot.